Okay, you guys need to know this. This is basically going to be theory. There will be a question on the diploma that has to relate to this. So the better you get at being able to read graph, the better you will be.
Graph is like its own language.
So this is quite a common experiment. We don't have not a spark timer, but I can't remember what it's called, but it like takes pictures of the velocity of a vehicle and it launches it so you have a constant speed. But a student collides two identical carts together in a head-on collision. The student varies the velocity of cart 1 for each trail but ensures that the velocity of cart 2 remains the same. The student also ensures that after each collision the cars stick together. The student measures the resultant velocity of the two cars stuck together after the collision. To keep the experiment somewhat simplified, the student put the carts on a set of tracks to keep the carts on a linear path before and after the collision. So this is trying to create an isolated system. Okay. The student also decides to always make the speed of cart 1 greater than cart 2 so that the two carts stuck together after the collision will always head in the same direction as cart 1. So this is trying to control as many variables as possible. They ran it a couple times and collected several pieces of data. So you can see from this graph that this is final speed of the combined carts versus the initial speed of cart 1. Very plain, straightforward heading. Here on the x-axis, we're going to see the initial speed of cart 1 right here, and on the y-axis, the final speed, and we see that it's in meters per second, centimeters per second, sorry. So something to pay attention to. Okay, it's asking us what's the theoretical value of the slope. Interpret what the slope value means and use the graph to calculate the velocity of cart 4. So when you look at this, when you flip over your page, you will see the graph beside the blank page, so you can kind of have them open and see at the same time. But as per usual, we're going to draw diagrams. So much for aligning my smartboard. So before they had one cart, this is cart 1, and then they had cart 2. Cart 1 always had a mass greater than cart 2 so that when they collided, they would go in the same direction. So cart 1 is heading in this direction, and cart 2 is heading in this direction. So this is mass 1, velocity 1, this is mass 2, and velocity 2. One of the things that it stated in the other part was, in the second sentence, the student varies the velocity of cart 1 for each trial, it should be trial, not trail, but ensures that the velocity of cart 2 remains the same. So this is constant. Okay, and then in our after picture, they always had it so that cart 1 and cart 2 stuck together, and we're heading in the same direction as cart 1. So you have 2 mass and velocity prime, before and after. Okay? So we're going to let V1 equal x. And we're going to have, because that's, this comes from the graph. Okay. So M1 V1 plus M2 V2 is going to be equal to 2m times v prime. And this is momentum before, this being equal to momentum after. Remember the conservation of linear motion? So if we're looking for the velocity of the V prime, we would see that we would have, whoops. Okay. And if we were to break this out, because this mathematical sentence here is the same as this mathematical sentence here. Okay, do you guys agree with this part here? That it's the same mathematical sentence. When we break that apart, we see that our masses are not a factor in here, but that our velocities are the factor. So from that, we see that V1 plus V2 over 2 equals V prime. That's what we're seeing. And if we leave it, actually we'll leave it in this format over here. Sorry. It makes more sense if I do it this way. Okay, do we agree to this part here when we simplify it? All I'm going to do is I'm just going to rewrite it so that V prime is on the left-hand side, because that's how we're traditionally used to seeing stuff like this. That's all I've done is just flip them around. Now, we know this formula here when it said calculate the slope. Number one said, what is the theoretical value of the slope? Well, we know that slope formula looks like this. Mx plus b. So, going from this pattern here, v prime, and we said that up here, v prime is y, and that v1 is x, the initial velocity. So you would have m being the slope, or not the slope, the slope. Ooh, drew a blank there. Hello, Mr. Spence.
Hi, how's it going?
Good.
This is a really big class.
It is huge.
Do you need help with something? I'll come help you.
No.
I do potentially.
This is 2/3 of my class.
Can I interrupt for just 1 second, even though I already have?
Okay. 2 seconds.